if f of x equals x cubed plus x squared minus 5x minus 5, find the interval on which f is increasing and the interval on which f is decreasing. So the function f of x is equal to x cubed plus x squared minus 5x minus 5. So for the interval for which f of x is decreasing, f prime of x must be less than 0. And the interval for which f of x is increasing, f prime of x must be greater than 0. So f prime of x is the derivative of f of x. So let's find f prime of x. So if you differentiate x cubed, you get 3x squared. If you differentiate x squared, you get 2x. If you differentiate minus 5x, you get minus 5. If you differentiate minus 5, it's a constant, so it's 0. So now, this is equal to 3 times minus 5 is minus 15. So two numbers that if you multiply, you get minus 15. But when you add, you get 2. So you see that 5 times minus 3 is minus 15. And 5 minus 3 is 2. So this becomes 3x squared minus 3x plus 5x, then minus 5. So we can factorize 3x from here. We are left with x minus 1. And in this case, we can factorize 5. We are left with x minus 1. So we have in one bracket 3x plus 5. Then in another bracket, x minus 1. So this implies that f prime of x is equal to, in one bracket, 3x plus 5. Then in another bracket, x minus 1. So let me repeat f prime of x here. So f prime of x is equal to, in one bracket, 3x plus 5. Then in another bracket, x minus 1. But we said for interval for which f of x is decreasing, f prime of x must be less than 0. This implies that 3x plus 5 times x minus 1 is less than 0. So in this case, you can see that the critical points are x equals minus 5 over 3 and x equals 1. So let's draw a number line here. So here is minus 5 over 3 and here is 1. So let's pick values less than minus 5 over 3. For example, minus 2. So 3 times minus 2 is minus 6. Minus 6 plus 5 is minus 1. And then minus 2 minus 1 is minus 3. So minus 1 times minus 3 is 3. So in this case, you see that f prime of x is greater than 0 in this region. Let's pick values greater than 1. So for example, 2. 3 times 2 is 6. 6 plus 5 is 11. And then 2 minus 1 is 1. 1 times 11 is 11. So you see that in this region too, f prime of x is greater than 0. Now let's pick values between minus 5 over 3 and 1. For example, 0. 3 times 0 is 0. 0 plus 5 is 5. And then 0 minus 1 is minus 1. 5 times minus 1 is minus 5. So in this region, f prime of x is less than 0. So you can see that for the region in which f of x is decreasing, we have this interval, which is in this region. So x is greater than minus 5 over 3, but less than 1. Now, in maths, if you see open bracket, it means the endpoints are not apart. But when you see closed bracket, it means the endpoints are apart. So another way we can rewrite this is open bracket minus 5 over 3, comma 1. So let's find the region in which f of x is increasing. So that is this region. And that is x is less than minus 5 over 3. And then this region, x greater than 1. So another way we can write this is open bracket minus infinity, that is here, comma minus 5 over 3. Then in union with this region, which is 1, comma infinity.